Hello everybody, welcome to section 4.8. I would encourage you to read the notes in Canvas that go over the growth and decay models and what the terms mean. And just another note that you don't have to always use growth of cells to be the n of t equals n naught e to the kt, and decay to be a of t equals a naught e to the kt. They're all just different forms of the same thing, so you can just, even if you are happy with a equals p to the p times e to the rt, you can use that. I'm just gonna follow the book's notation. So in our first example, we have a colony of bacteria that's growing according to the law of uninhibited growth, according to the function n of t equals 100 times e to the 0.045 t, where n is measured in grams and t is measured in days. We want to determine the initial amount of bacteria. We want to know what is the growth rate of the bacteria, what is the population after 5 days, how long will it take the population to reach 140 grams, and what is the doubling time, oops, an extra I, for the population. So when we are doing this problem, it's good just to note that in this case we've been given the formula. In some cases we will want to find the formula, and we see that t is in days, n of t is the amount of bacteria, so grams of bacteria. And so in this first question, we want to determine the initial amount of bacteria. And so if you reference the notes on Canvas, you can spot that 100 is the initial amount. It's this value that's here. Now let's put grams is the initial amount. And I just want to note as well, another way that you can find the initial amount is going to mean that the number of days is going to be 0, and you would find n of 0, and then that would be 100 times e to the 0.045 times 0. This is going to give you e to the 0. E to the 0 is 1, and so you get 100 times 1, or 100 grams. The second part of the question is, what is the growth rate of the bacteria? And this is just seen from the formula, and the growth rate is the k, which is 0.045, and we can also write that as a percent, so 4.5%. And we notice that since k is greater than 0, that the expression here is going to be positive exponential growth, so meaning that this is exponential growth. The next question is, what is the population after 5 days? So this boils down to finding n of 5. So you're going to plug in 5 for t, and then evaluate that in the function, times 5. And then just use your calculator. I end up coming out with 125.23 grams. And in this instance, I don't specify how to round. Make sure that in your homework and on quizzes or exams that you just see how many decimal places to round to. If not, just use a reasonable decimal place to round to, and just make sure you're rounding correctly. The next question is, how long will it take the population to reach 140 grams? So in this part's case, we're given the number of grams, we want to know the t. So that means we're going to go ahead and solve 140 equals 100 e to the 0.045 t. We'll recognize that this is an exponential equation, and so that means we have to isolate the exponential. We can divide both sides by 100, getting us 1.4 will equal e to the 0.045 t. In order to bring the t down, and since the base is e, we'll natural log both sides. And let's see if we can bring our work over here. And then, so this means we'll have natural log 1.4 equals the 0.045t comes down as a factor, and natural log of e is 1. So we have 0.045t, and to solve for t, we need to divide both sides by 0.045. And we'll get approximately 7.477 days. Okay, there's one more question. So we want to know for the last part, what is the doubling time for the population? Let's clear all this. Okay, so doubling time, it's just asking if our initial population is 100, how long would it take to double? And so based on our last work, based on what we did here, if it took 7.477 days just to get to 140, we should expect the answer to be not much longer than, well, 60 more grams, so we should definitely expect it to be more than 7.477 days. Okay, so what we want to solve, if it's going to double, is 200 equals 100 e to the 0.045 t. And we'll divide both sides by 100, kind of repeat the steps we just did. So we'll end up with 2 equals e to the 0.045 t, ln both sides. And then the 0.045 comes down as a factor, the 0.045t comes down as a factor, and ln of e is 1, leaving us with ln 2 equals 0.045 t. Divide both sides by 0.045, and t will equal ln 2 divided by 0.045. which is approximately, I'm getting 15.403 days. Alright, so that is how we do this last part. I'll see you in the next video.